Hey, everybody, and welcome to another deep dive. Today we're going to take a look at how data gets around the internet.
Like a postal service.
Oh, yeah, exactly, like a postal service. But instead of letters,
Packets.
packets, yeah.
Yeah.
And, those postal services need, like, routes to be efficient.
Right, and the internet's the same way. That's where routing protocols come in.
Okay, so routing protocols, like what?
Specifically, the distance vector routing protocol we'll be taking apart today.
Distance vector routing protocol. So I've heard about routing tables,
Yeah.
but honestly, they've always been kind of a mystery to me. So,
Okay.
like, what are they and how do they fit into this distance vector thing?
Well, imagine each router has its own little, map,
Uh-huh.
and that map lists all the possible destinations and the best path to get there.
Okay.
And that's essentially what a routing table is.
Okay, so each router has its own
Yeah.
routing table.
Yeah, and distance vector routing, those tables are constantly being updated based on information shared between neighboring routers.
So like they're all talking to each other
Yeah.
and being like, "Hey, this is the best route."
Yeah, it's like a constant game of telephone
Oh, really?
with routers whispering their routes to each other.
Oh, wow, I like that.
Yeah.
Okay, so it's like gossipy routers.
Yeah, you could say that.
Oh, that's funny. Okay, so we're looking at the simulation of distance vector routing algorithm source today,
Right.
and it mentions a cost matrix.
Yeah.
I'm guessing that this isn't about like money though, right?
No, not about dollars and cents.
Okay, good.
Nah.
No,
Oh.
I was a little worried about that. So what does cost mean in this context then?
So cost represents a combination of different factors that kind of determine the efficiency of a path.
Uh-huh.
So it could be the physical distance between routers, the speed of the connection,
Okay.
or even the amount of congestion on a particular link.
Oh, okay. So like traffic.
Exactly.
Yeah. So are routers just trying to find the lowest cost paths then?
Yeah, essentially.
Okay. To get data from point A to point B as quickly as possible.
As quickly and efficiently as possible.
Right, quickly and efficiently. Okay, I got it.
And that's where the distance vector algorithm really shines.
Okay.
By sharing their routing tables with their neighbors, routers can learn about all the alternative paths and update their own tables to reflect the most optimal routes.
Okay. I'm starting to get the picture here.
Good.
But this simulation of distance vector routing algorithm source also mentions something called a routing loop.
Yeah.
What in the world is that?
So imagine
Great.
link between two routers goes down.
Okay.
If information about this change doesn't get to the other routers quickly enough,
Uh-huh.
they might keep sending data along that broken path,
Oh, no.
and it creates a loop where packets just keep circling around.
So it's like a digital traffic jam
Yeah, basically.
with data packets stuck in a roundabout with no exit?
Exactly.
Well, that sounds terrible.
It definitely is a problem.
Yeah.
And it kind of shows one of the limitations of distance vector routing.
Yeah.
The networkinglab.pdf source actually goes into this a little bit more
Okay.
and talks about other protocols that can maybe address those limitations.
Interesting.
Yeah.
Okay, but before we go to those other protocols,
Right.
the outline for this deep dive actually mentioned the Ubuntu terminal
Yeah.
as a way to illustrate how all this routing stuff actually works
Yeah,
in practice. So
for sure.
can you tell us a bit more about that?
Absolutely. Ubuntu is a really popular Linux distribution, and it's got some super powerful networking tools that can be used to watch and even manipulate routing behavior.
Wow.
Yeah. And the CSL 332 Networking Lab KTU 2019 scheme, Dr. Binu VP source, lists a bunch of these commands and tools,
Yeah.
which are really useful for understanding how routing works on a real system.
So we can see like the actual paths the data packets take,
Yes.
the hops that they make, and maybe even like simulate those routing loops that we just talked about.
Yeah,
That's awesome.
Yeah, and what's really cool is that you can actually use these tools alongside that C program from the simulation of distance vector routing algorithm source.
Really?
So by comparing the simulation's output to what you see in the Ubuntu terminal,
Okay.
you can really start to connect the dots between the simulation and the actual reality of network routing.
So we're not just like talking about theory here.
No.
We can actually see it happening in a real system.
Yeah, for sure.
That's so cool.
And that's the beauty of this deep dive. We're not just talking abstract concepts,
Huh.
but we're giving you the tools and the knowledge to experiment with routing yourself.
Wow.
See firsthand how it all works.
Yeah, this is making me want to fire up my Ubuntu terminal right now and start messing around with stuff.
Awesome.
But before we get too far ahead of ourselves,
Right.
I think we should take a closer look at that C program first.
Okay.
And see how it actually simulates those core mechanics of distance vector routing.
Sounds good. Let's do it. Okay.
Okay, so let's take a closer look at this C program from the simulation of distance vector routing algorithm source.
Okay.
What are like the key elements that we should be paying attention to here?
The heart of it is how it represents the network in the routing tables.
Okay.
And it uses a cost matrix to
Yeah.
define the connections between the routers. And each cell in the matrix represents the cost of traveling between two specific routers.
So it's like a spreadsheet
Yeah,
with like rows and columns
exactly.
to represent each router.
Yeah,
Okay, and then the cells like at the intersection.
yeah,
That shows the cost of going from one to the other.
yeah, exactly.
Okay, cool. And then,
And the program also defines a structure to represent each router's routing table,
okay,
which stores information about the destination networks, the cost to reach them, and the next hop router along the path.
so it's like each router has its own little map
Right,
of the network.
exactly.
And that's constantly being updated
Yeah.
with information from its neighbors.
Precisely. The core of the distance vector algorithm is implemented in a function that iteratively updates those routing tables,
Okay.
and it simulates the process of routers exchanging information and recalculating the best paths.
So earlier you mentioned that we could use the Ubuntu terminal
Yeah.
to observe routing in action. So
Yeah.
how does that tie in with this C program?
So think of the C program as a simplified model of a real network.
Okay.
It helps us understand the basic principles of distance vector routing.
Mm-hmm.
But to see how it works in a real-world system, we can use commands like traceroute in the Ubuntu terminal.
Oh yeah, I've used traceroute before
Yeah,
to like see the path that my data takes
yeah.
to reach a website.
It is fascinating to see
Yeah, it's really cool.
all the different hops between routers.
Yeah, and by comparing the output of traceroute with the routing tables generated by our C program,
Right,
we can start to connect the dots
Yeah.
between the simulation and reality.
exactly.
That's awesome. So we're not just talking about like abstract algorithms. We can actually see this happening
Yeah, we can see it
with our own eyes
in a real system.
in a real system.
Yeah.
That's so cool. Okay. And
For the CSL 332 Networking Lab KTU 2019 scheme, Dr. Binu VP source actually provides a ton more information about other networking commands and tools
okay,
that are available in Ubuntu. So there's a whole toolbox waiting to be explored.
this is really making me appreciate like the depth of knowledge and
Yeah.
skill
For sure.
required to manage these complex networks.
Right.
It's like a hidden world
It's like this.
that's operating behind the scenes,
Yeah.
making sure our emails get delivered, our websites load, and our cat videos stream smoothly.
It really is amazing when you think about it like that.
Yeah.
And understanding distance vector routing, even with its limitations, is a fundamental step towards appreciating that complexity and ingenuity of internet infrastructure.
Okay, so speaking of limitations,
Right.
we talked about routing loops earlier.
Yes.
How does this C program handle those? And are there any Ubuntu commands that can help us visualize them?
So the C program, being a simplified simulation,
Okay.
doesn't explicitly model those routing loop scenarios,
Okay.
but it does demonstrate how changes in the network topology, like a link going down,
Mm-hmm.
can trigger updates in those routing tables.
So we could potentially like modify the cost matrix
Yeah.
to simulate a broken link and see how the algorithm reacts.
Exactly. That's a great way to experiment.
Oh, that's cool.
And observe how the iterative updates might lead to those temporary inconsistencies or even routing loops if the
Okay.
information doesn't propagate quickly enough.
In a real world scenario, could we use commands like
Yeah.
ping or traceroute in
Yeah.
Ubuntu
Yeah.
to detect if we're experiencing a routing loop?
Yes, if you're sending packets to a destination and they're not arriving,
Okay.
or if traceroute shows the packets going around in circles,
Mm-hmm.
that's a strong indication of a routing loop.
This is really bringing it to life for me. Like,
It is.
it's not just a theoretical problem. It's something that can actually happen
Yeah, it can happen
and cause real disruption.
and cause disruptions, yeah.
Okay, so we've explored the C program.
Uh-huh.
We've talked about some Ubuntu commands.
Yeah,
But there's another source we haven't really talked about yet.
right.
The simple TCP/IP client-server example.
Yeah.
How did that fit into our exploration of distance vector routing?
That source gives a practical example of how routing is a crucial part of everyday internet communication.
Okay.
So it shows the C code for a simple client-server program,
Okay.
illustrating how data is sent and received over a network.
I'm curious, how can a client-server program
Yeah.
help us understand the complexities of routing protocols?
So while the code itself doesn't really go into the specifics of distance vector routing,
Okay.
it does highlight the importance of IP addresses and ports in network communication.
Right. So each computer on the internet needs a unique IP address.
Exactly.
Applications use specific ports to talk to each other.
Yeah.
But how does that relate to routing?
So when a client program wants to send data to a server,
Right.
it needs to know the server's IP address
Uh-huh.
and the port number that the server is listening on.
What?
This information is included in the data packets that get sent over the network.
So the routers use this IP address
Yes.
and port number information
Exactly.
to figure out where to deliver those data packets.
Exactly. The routing tables we've been talking about come into play here.
Oh.
They guide the packets through the network, making sure that they reach the correct destination server
Okay.
and the intended application on that server.
So it's like the IP address and the port number are like the street address and the apartment number.
Yeah, that's a great analogy.
And the routers are like the postal service,
Yeah,
delivering the data packets
perfect analogy.
to the right destination.
Exactly.
Okay.
It captures the essence of how routing works.
Okay, so even though the simple TCP/IP client-server example source doesn't deal directly with the distance vector routing protocol,
Right.
it still provides a valuable illustration of how routing is essential
Yeah.
for any internet communication.
It reminds us that all those complexities of routing protocols,
Uh-huh.
the algorithms, the routing tables, the updates,
Yeah.
are all serving a purpose
Okay.
to enable seamless communication between devices
Right.
across this vast expanse of the internet.
Wow. Okay, so we've explored this C program that simulates distance vector routing.
Right.
We've talked about using Ubuntu commands to observe routing in action. And we've even touched on a simple client-server example to see how routing plays a role in like everyday internet communication.
Yeah,
It's been quite a journey.
it really has. And it just shows how understanding even a seemingly simple protocol like distance vector routing can help us understand how complex and interconnected the internet really is.
But distance vector routing isn't the only game in town, right?
Right.
The networkinglab.pdf source mentioned other routing protocols like link state routing.
Uh-huh.
What are the key differences between them?
Okay, so that's a great question.
And why did we need to like move beyond distance vector routing?
So as networks got bigger and more complex,
Okay.
the limitations of distance vector routing became more apparent.
Okay.
Things like slow convergence,
Uh-huh.
the potential for those routing loops.
Right.
These issues can cause huge disruptions in large networks.
So link state routing was developed to address these shortcomings.
Yeah, basically.
Okay, so how does it work?
So link state routing takes a different approach.
Okay.
Instead of only relying on info from neighbors,
Uh-huh.
routers in a link state routing network actually maintain a complete map of the entire network topology.
A complete map. How do they even manage that?
It involves a lot more communication and coordination between the routers.
Okay.
They periodically flood the network with information about their directly connected links.
Okay.
And this allows every router to build a comprehensive picture of the network.
So it sounds a lot more complex than distance vector routing.
It is, but that complexity comes with some pretty significant benefits.
Okay, like what?
So link state routing typically converges a lot faster.
Okay.
It avoids the issue of routing loops.
Yeah.
And it offers more flexibility when it comes to actually picking a path.
So the trade-off
Yeah.
between simplicity and performance.
Exactly.
Distance vector routing might be fine for smaller networks where it's easy to implement,
Right.
but for larger, more demanding networks, link state routing is essential.
Exactly.
Okay, so this kind of reflects the constant innovation that's happening in the field of networking, right?
Yeah,
Like
definitely.
as demands on the internet grow, we have new challenges, and engineers have to develop new solutions to keep up.
Exactly.
This deep dive has really opened my eyes to the inner workings of the internet.
Good.
It's just amazing to think that all of this routing magic is happening behind the scenes every time we send an email or browse a website or stream a video.
It's a testament to the engineers who designed and built this huge global network.
Yeah.
They had to think ahead, anticipate challenges, come up with solutions, and constantly refine their approaches to make sure that data can flow seamlessly across continents.
It makes you realize how much we take the internet for granted.
Yeah,
We just expect it to work.
we do.
But there's so much going on behind the scenes to make that possible.
There really is.
Yeah, and as we move toward an even more interconnected future
Right.
with the Internet of Things and these ever-increasing demands on bandwidth,
For sure.
the role of routing is only going to become more crucial.
Absolutely.
So what's the key takeaway for our listeners today?
Okay, so I think the most important thing to remember is the idea of routing tables
Okay.
and how they guide those data packets through the network.
Ah,
Even though distance vector routing has its limitations,
yeah.
understanding the basic principles provides a solid foundation for exploring those more advanced routing protocols.
And don't forget the power of the Ubuntu terminal.
Oh, yeah.
You can peek behind the curtain
Right.
and observe routing in action
Yeah.
and gain like a hands-on understanding of how the internet works. So keep that curiosity alive. Keep learning and keep exploring those intricate pathways of the internet. Until next time, happy routing.
Happy routing.